Today, we're going to go over the second great thing every student knows in mathematics, the quadratic formula. You know the one. Minus b plus or minus the square root of b squared. Wait. If you're like me, you hate this thing. If you're not like me, you probably still hate it, but for different reasons. Let's have a look at an alternative way to do the exact same thing that is a million times less this. We're going to be shortening the idea from 3 Blue 1 Brown's recent video on this topic, which itself is based on a video by Po-Shun Lo. Both are linked in the description. To start off, we want to talk about quadratics that look like x squared plus b prime x plus c prime equals 0. We could instead discuss quadratics like ax squared plus bx plus c equals 0, but those aren't as easy, and besides, if all we want is an equation to equal 0, wouldn't it be nice to work with a simpler one? We can justify leaving off that a in two parts. First, we can divide the whole equation by a to get a thing that looks like x squared plus b over ax plus c over a equals 0. Second, we can show on a graph that as long as we don't multiply or divide by 0, the places where the expression is 0 don't change when multiplying. Okay, great. So we start with ax squared plus bx plus c equals 0. Divide by a and rewrite. X squared plus b prime x plus c prime equals 0. Now we can get started. We turn back to the graph for a moment. We're going to do some steps here. First, those zeros are going to be called r and s. Second, we can write an equation using r and s that represents our situation. X minus r times x minus s equals 0. Third, we do that weird multiplication thing to get x squared minus r plus s x plus rs equals 0. This tells us two important facts. Namely, b prime is minus r plus s, and c prime is r times s in our simplified equation. Fourth, we identify the middle of r and s. Call it m. We know the zeros are the same distance from m. We'll call that distance d. But that means the product rs can be written as m minus d times m plus d. We do that weird multiplication thing again to see that r times s is m squared minus d squared. But wait, c prime was r times s, so c prime now is m squared minus d squared. Or in other words, d is the square root of m squared minus c prime. And this gets us to the point we need it to be. Why? Because r and s are our zeros. But we can write those together as x equals m plus or minus d. Hey, we know how to find d, so let's put that in there. Well, now we know c prime, and the only thing we're missing is m. Wait, m was the midpoint of r and s. We can write that as the average of the 2 points, so m is just r plus s over 2. We've seen something like that already. It was in b prime. Great, so now we can write the whole solution like this. If x squared plus b prime x plus c prime equals 0, then x equals m plus or minus the square root of m squared minus c prime, where m is just minus b prime over 2. What's easier to remember, this or that? Before we leave off, let's see this in action. Suppose we want to solve 2x squared plus x minus 6 equals 0. We divide off the 2 to make the equation a bit nicer. Now we have x squared plus x over 2 minus 3 equals 0. Under our labels from before, b prime is 1/2 and c prime is minus 3. So m is just minus b prime over 2, or minus 1/4, and our answer is x equals m plus or minus the square root of m squared minus c prime, or minus 1/4 plus or minus the square root of 1/16 plus 3. After simplifying, this is minus 1/4 plus or minus the square root of 49 over 16, or minus a quarter plus or minus 7/4, then our answers are just minus 2 and 3 over 2. Now tell me, which way would you prefer?